All right, today we're going to talk about angles and their properties, specifically vertical angles, complementary angles, and supplementary angles. So the first angle we're going to talk about is vertical, and the definition is it's formed by two opposite rays. Visually, vertical angles are going to form an X. So if we look at the theorem here, what's important is that vertical angles are going to be congruent. And because it's congruent, we're going to use that to set up equations, which we'll see in a few minutes. So if we look at this example here, naming an angle with three letters, we have angle DAB, which is this angle right here, is congruent to angle EAC. And if we see they make an X, and then these two angles right here are congruent. Now these angles here, BAE and CAD, are also congruent. So do not be confused, because these angles are not necessarily vertical in alignment, but that's the name that we give them. And the property that vertical angles have is they're congruent. All right, so if we look at this example here, let's find the measure of X. So if we look at this angle and this angle, we have to identify first what they are. So first identify what type of angle. Okay, and this type is vertical angles. The second thing is what property do they have? And we know that vertical angles are congruent. So we're going to set up an equation that looks something like this. 4x minus 101 equals 2x plus 3. By using our formula steps here, we're going to find the smallest variable term, subtract that. We're going to do opposite of the number to get numbers on one side, variables on the other, and divide to get 52. But we're not done, because the directions say find the measure of the vertical angle. So now we have to plug them in. All right, so we're going to substitute it in. So I decided to take the 2x plus 3 and substitute in 52 to get a total angle of 107. Now this angle is 107, and so is this, because vertical angles are congruent. All right, the next angle we're going to talk about is called an adjacent angle, and that just means the angles are next to each other. So in this case, angle 1 is next to angle 2 and angle 4. Angle 4 in this case is next to 1 and next to 3. There's no other properties other than that. They're just next to each other. They're neighbors. All right, complementary angles are angles that add up to 90 degrees. One way to remember that is that complementary starts with C, and a C can make a 9 if you get a little creative there. Okay? So in this example here, we see that these two angles add up to 90, which makes them complementary. A linear pair is a pair of angles that make a line, and a line adds up to 180 degrees. And when something adds up to 180 degrees, we call that supplementary. One way to remember supplementary is 180 is an S, can make an 8 if we get a little creative with it. All right, down here we see a linear pair, and if we add those up, they equal to 180 degrees. Okay. All right, so here's an example. It says A and B are complementary. So looking at that sentence, we have to know that this means they're going to equal to 90 degrees when we add them up, right? And then it gives us the two angles. So here would be our equation. The first angle, A, plus angle B equals to 90. We would combine like terms, so we get 5x and then minus 10. We would add 10 to both sides and then divide by 5 to get 20. If we look at the directions, they want you to now plug it in. So I'm going to pick this one first. So we do 3 times 20, and again, the 20 came from x. So 3 times x is 20, plus 12 is 72. Now, unlike the vertical angle, this is not the same. These are gonna add up to 90 degrees because it says it's complementary. So one way we can do it is 90 minus 72, which gives us 18. That would be one way to find the second angle. The other way is to take this term, plug in 20, and get your value. In either way, you should get 18. All right, a couple things with diagrams to conclude is if angles are next to each other, we can conclude that. If angles are vertical, because they make an X, that's what we're looking for, vertical angles, then you know that they're vertical. And if you have a straight line with two angles, like something like this, we know that this angle and this angle are going to add up to 180. There are a few things we can't conclude, that things are congruent unless we're given symbols. If angles are actually right angles, unless we're given a symbol or it tells us, or something is parallel or perpendicular, again, unless there's a symbol or they tell us. All right? So here's a type of problem just in identifying types of angles. So complementary angles in this problem are going to be 3 and 4. Because they give us the symbol, we can conclude that. A linear pair are two angles that are going to make a straight line. So one pair is this, angle 1 and angle 2. Another pair is angle 2 and 3 because they make a straight line. Vertical angles in this problem are angles which make an X. And if we look here, there's only one pair. It would be 1 and 3. All right, adjacent angles, there's many of them. 5 and 4, 4 and 3, 3 and 2, 2 and 1, and 1 and 5. These are just angles that are next to each other. Okay, in the next example here, what angles are vertical? So again, we're looking for angles that make an X. So there's the X in this particular problem. And so that's going to be 3 and 5. What angles are adjacent to 1? This is going to be 5 and 2. All right, what angles are supplementary? That would be 3 and 4, and 4 and 5. What angles are complementary? In this example, we actually don't have enough information. Even though these are congruent and it looks like it's 90, they don't actually tell us that it's 90. What angles are congruent? Well, 1 and 5 are congruent because they have congruency marks, and 3 and 5 are congruent because they're vertical. And what angles are 90? We still don't know. This theorem here, we don't really need to worry about too much. So hopefully that explains vertical and supplementary and congruent, complementary angles.